There is a spinning device that sits on top of a roof and pulls scorching air out of your attic without consuming a single watt of electricity. Independent testing proved it reduces peak attic temperatures by 37 degrees Fahrenheit and cuts your cooling bill by nearly 15%. It has no wiring, no motor, no circuit board, no battery, and no monthly cost of any kind. It was a standard fixture on warehouses, farm buildings, and residential rooftops across the United States and Australia for decades. Then it vanished from new construction almost overnight. They did not stop installing them because they failed. They stopped because a $65 billion industry needed you to believe that only expensive machines could keep your house cool. A device that costs $20 and runs on wind cannot generate service contracts, annual maintenance fees, or replacement part revenue. And what cannot generate revenue must be forgotten. This is the story of the Turbine ventilator, the spinning sentinel that cooled buildings for a century and that the HVAC industry erased from your blueprint. Welcome to Forbidden Camping. If you are not subscribed yet, hit subscribe and the bell. This is where we dig up what the industry buried. The idea of moving air through a building without burning fuel is one of the oldest engineering solutions in human history. In ancient Persia, architects built tall masonry towers called bodgirs, wind catchers designed to funnel desert breezes down into the lower levels of stone buildings while pulling hot, stale air out through the top. These structures still stand today in the city of Yazd, functioning after more than 1,000 years, cooling homes in 120-degree heat. Air was regarded as one of the 4 essential elements, and cathedral builders designed soaring vaults specifically to manage airflow through massive stone halls. But all of these were passive systems, relying on the shape of the building and the direction of the wind to do the work. The push towards something more active began during the Industrial Revolution, when deep coal mines needed a way to keep workers alive underground. Engineers built fire-driven ventilation shafts and manually powered wooden fans that required constant fuel and constant labor. By the 18th century, the Houses of Parliament in London had installed a primitive mechanical blowing wheel to push foul air out and pull fresh air in. And by the 19th century, a man named David Boswell Reed was building steam-powered ventilation systems for hospitals and military barracks, where airborne disease made the movement of air a matter of survival. But all of these systems demanded fuel, infrastructure, and teams of workers to maintain them. The breakthrough came in 1910, when a Scottish engineer named Samuel Ewart patented a design for a spinning cowl that sat on top of a roof and actively pulled air out of the space below it. Ewart described his device in the patent filing as a solution for ventilation and preventing downdrafts in chimney stacks, those gusts of wind that blow soot and smoke back into a home. And unlike anything that came before his invention, this device had no fuel source, no electricity, and no human input of any kind. It simply sat on the rooftop, caught the wind, and spun. And while it spun, it dragged stale air upward and out of the building like a silent mechanical lung. Ewart could not have known that his patent would become one of the most effective passive. Within a decade of that 1910 filing, spinning turbine cowls appeared on factory rooftops across Glasgow, Manchester, and Birmingham, pulling toxic fumes out of textile mills where workers had been breathing cotton dust for generations. By the 1920s, the design had crossed the Atlantic, and American warehouse operators in Chicago and Detroit discovered that a row of spinning turbines along a factory ridge could drop interior temperatures by 20 degrees on a July afternoon without a single cent of operating cost. The Australian outback adopted them next, and by the 1940s, the whirlybird, as farmers called it, was as common on a corrugated iron shed roof as a weather vane. In the post-war American housing boom of the 1950s, builders installed turbine ventilators on residential rooftops as standard equipment, right alongside gutters and downspouts. Your grandparents almost certainly had one, and they probably never thought twice about it because it simply worked, year after year, spinning silently above the bedroom while the summer heat climbed past 100 degrees. And he certainly could not have predicted that an entire industry would one day work to erase it from the modern construction blueprint. Stay with me because the science behind this device is as elegant as it is devastating to the companies that want you to forget it exists. This video is just the surface. I have collected everything the energy industry does not want you to know, all in the complete Forbidden Camping vault. the off-grid cooling blueprint that shows you exactly how to slash your summer energy bill without touching your thermostat. The complete off-grid blueprint that covers solar, wind, and passive systems the utility company's grid failure they keep telling you will never happen. The forbidden firecraft manual with heating techniques that military units classified as too effective for civilian use. The lost rations cookbook with preservation methods that work without electricity, without refrigeration, and without a single dollar spent. And much more. Over 10 guides in one place, no fluff, straight to the point. Anyone still paying $300 a month in cooling bills while this knowledge exists in one vault is choosing to stay a customer when they could be free. The link is in the description. But stay here because the video is just getting started. During a typical American summer, solar radiation heats your roof shingles and turns the attic into a thermal furnace. Temperatures inside that sealed space can climb past 150 degrees Fahrenheit. That trapped heat does not just sit there. It radiates downward through the ceiling joists and into the living rooms below. Your air conditioning compressor runs longer, works harder, and burns more electricity just to maintain the same temperature on your thermostat. According to the United States Department of Energy, every single degree of attic temperature increase can boost your cooling load by up to 4%. And in most American homes, the ductwork that carries cooled air from the compressor runs directly through that superheated attic space. The entire point of attic ventilation is to break this brutal cycle by moving hot air out before it has a chance to radiate down. And that is exactly what Ewart's turbine was designed to do, using 3 separate principles of physics working together at the same time. The first is Bernoulli's principle, and you can see it in the curved aluminum vanes of the turbine head. As wind passes across those curved surfaces, the air is forced to accelerate, and when air speeds up, its pressure drops. This creates a zone of low pressure inside the spinning turbine housing that generates a powerful suction effect, actively dragging warm air upward from the attic cavity and exhausting it outside. Unlike a static roof vent that just sits there hoping air drifts through, the turbine ventilator uses the kinetic energy of the wind itself to pull air out of the building. The faster the wind blows across the rooftop, the harder the spinning turbine works. But here is what most homeowners never realize, and this is the part the HVAC industry prays you never learn. The turbine does not stop working when the wind dies down. It also leverages something called the stack effect, which is the natural tendency of warm air to rise because it is less dense than cool air. In a house with soffit vents at the eaves and a turbine at the ridge peak, that rising warm air creates a gentle pressure gradient that pushes air upward and out through the turbine housing, even when it is not spinning. The third principle is the Venturi effect. As air squeezes through the narrow gaps between the rotating vanes, its velocity increases, which further reduces pressure inside the turbine and accelerates the entire exhaust cycle. All 3 of these physics principles compound one another simultaneously. The result is a device that generates continuous negative pressure at the highest point of the building, pulling hot, humid, stale air out and replacing it with cooler air drawn in through the soffit vents below. A study by the Air Infiltration and Ventilation Center found that installing a turbine ventilator increased attic ventilation rates by an average of 15% over a full year. Improvements climbed to 50% when the wind hit the spinning unit from its optimal compass direction. And data collected in the San Diego region showed that a properly installed turbine system reduced peak attic temperatures by 37 degrees Fahrenheit, which translated to an average energy bill reduction of 14.6%. A standard 12-inch turbine moves between 250 and 350 cubic feet of air per minute at just 5 miles per hour of wind speed. A 14-inch unit pushes that to between 350 and 500 cubic feet per minute. And because the device consumes 0 electricity, every single dollar of cooling savings goes straight back into your pocket. Those numbers should change the way you think about cooling your home forever. But they should also make you furious, because what comes next explains why you were. If you have made it this far, you already know more about cooling your home than 99% of homeowners in this country. Share this with someone who just wrote a $300 check to the electric company last month. And remember, everything the energy industry buried is in the complete vault. The link is in the description. Now stay with me because the next vault is the heaviest. So why did the turbine ventilator disappear? If it works, if it costs $20, if it has been proven effective since 1910, why is it missing from every new housing development in America? Because the HVAC industry in the United States alone generates over $65 billion a year in revenue. The residential cooling market adds another $15 billion on top of that. American consumers spend more than $10 billion annually just on HVAC repair and maintenance. 88% of all American households use air conditioning, two-thirds of them running central AC systems that consume thousands of kilowatt hours every single summer. A spinning aluminum device on your rooftop that cuts cooling costs by 15% without using a single watt of electricity does not fit inside that business model. You cannot sell a service contract on a device with no electronics. You cannot charge an annual maintenance fee on a product that requires a squirt of oil every 2 years. You cannot build a replacement parts revenue stream around something that has no parts to replace. The entire economic architecture of the cooling industry depends on your home requiring a complex mechanical system that only a licensed technician can install, diagnose, and repair. A turbine ventilator represents everything that model fears. It is passive, it is permanent, it is nearly free, and it makes your expensive air conditioner work less. But they could not simply ban it, that would be too obvious. So they used 3 forces working in parallel to make it disappear. The first force was homeowners associations, those governing boards that control the appearance of suburban neighborhoods across the country. Turbine ventilators are visible from the street, and in the American housing market, curb appeal drives property value. Ridge vents, by comparison, are shingle-covered designs that are nearly invisible from the sidewalk. Homeowners associations across the country have restricted or outright prohibited turbine ventilators because they disrupt the clean, uniform rooflines of modern developments. Even in Florida, where state law protects energy-saving devices, many associations worked around this by requiring turbines to be placed on the rear slope of the roof only. That rear placement often faces away from the prevailing wind direction, reducing the device's effectiveness to nearly zero. The second force was building codes. As American homes became tighter and more energy efficient, codes like the International Energy Conservation Code and California's Title 24 began mandating mechanical ventilation systems that guarantee precise air exchange rates. Because a passive turbine depends on wind speed and temperature, variables no one can control, it falls into a regulatory gray area that makes it easier to exclude than to approve. The codes were not written by homeowners. They were written by committees with deep ties to the companies that manufacture the mechanical systems those codes require. The third force was the cheapest trick of all: manufacturing junk. Budget manufacturers flooded the market with poorly made turbine units using inferior ball bearings that degraded within 2 years. Those cheap bearings produced a squeaking, grinding noise that transmitted through the roof structure and into the bedrooms below. That noise gave the turbine ventilator a reputation as unreliable hardware, a reputation the HVAC industry was happy to amplify. Not because all turbines were noisy, but because the noise gave them a story to tell. A story that said, "Forget the spinning thing on your roof and buy our $3,000 system instead." Think about the math for a moment, because the numbers tell the real story. The average American household spends $2,000 a year on cooling costs alone, and that number climbs to $3,000 in the Sunbelt states. A pair of quality turbine ventilators costs about $200 installed, reduces that bill by roughly 15%, and lasts 20 years with nothing more than a drop of oil. That is $6,000 in savings over the life of the device, money that would otherwise flow directly into the pockets of utility companies and HVAC contractors. Multiply that by the 88 million American households running air conditioners every summer, and you begin to understand the scale of what they are protecting. Here is what you need to know if you are ready to take your cooling back.